Okay, so here are the two ways of how to hook up the weightDriver. First step would be manual, and the second step would be via shapes. So what I'm going to do is I want to correct my shoulder deformation here when the arm goes down. And so the rotation of the upper arm should drive the corrective shape. So it should look like when I'm selecting the mesh, going to the blend shape, left arm down. So that would be the corrective shape. So this one needs to be driven, and in order to hook it up manually, this one is off. First we're gonna create the weightDriver node. So create node weightDriver. Up, and this puts the weightDriver node in our scene here. And first of all, we need to be in that pose where the corrective shape should be driven. So that would be here where my arm is down, and the weightDriver node needs to be in basically in the position where the upper arm is. So right now, just for demonstration purposes, I'm using my FK upper arm joint. Usually this would be the skinning joint, driven by either the IK or the FK. But just for demonstration purposes, I use the FK upper arm joint here. So first I'm gonna take the weightDriver node and parent it to the upper arm joint. Just to be able to place it correctly and also rotate it correctly. Let's go into wireframe mode, and you can see it's placed here. The orientation is a little bit wrong, but just because my arm, the down axis of the arm is the Z axis in my case. So in the weightDriver shape now attributes, I set the direction to Z, and then maybe invert it. We have to check this. It depends on how the joints are set up. But at this point we cannot have it be parented to the up arm joint, because then the weightDriver would rotate along with the joint. So we rather want to have it stay in place. So we take the weightDriver and parent it to the parent of the up arm joint. So in this my case, this would be the left arm gimbal control. Parent it up there, and then you can see that it stays in place even though the arm rotates. Okay, that's the first step. The second step, we need a locator, which drives the gives a direction to the vector angle reader. So we just create a simple locator and parent this one to the lower arm joint. Lower arm joint parent, zip. Then we can use the channel box to reset everything. And actually the locator needs to be parented to the, well, it can be parented to the lower arm joint, but can be parented to the upper arm joint as well, because the weightDriver is parented to the basically the shoulder, and the locator now, being a child of the upper arm joint, moves along with the arm. And now the theory is that how it works is that we have now a vector between the weightDriver node and the locator, and when the locator comes into the range of the weightDriver node, then the value gets driven. So everything is placed correctly here. So we have the weightDriver node, we have the locator node. They're both integrated into the rig, and now we need to hook up everything. So that's actually a three-step process. We need to connect some matrices and then connect the output value of the weightDriver node with the blend shape node. Okay, are we going to do this? First, we're going to open the connection editor. You can do it with the node editor. I'm not a big fan of the node editor. I just rather do everything through the connection editor, but that's up to you. Doesn't matter, because just some connections we got to do. Okay, first of all, the driver should be the just as described in the in the documentation where you can download the weightDriver node. First select the transform node of the weightDriver, reload it here, and then we need to select the shape node of the weightDriver. Just select this one, arrow down to select the shape node and reload it to the right side. Okay, from the weightDriver transform node we need the world matrix and connect this with the, where is it? Down here, with the reader matrix. So just make sure that the left and right display have show non-keyable and also show hidden, because some of these attributes are hidden by default. So the world matrix of the weightDriver transform node, so this one, goes into the weightDriver shape node reader matrix. And then on the other hand, we select the locator, reload left, and use its world matrix and connect it with a driver matrix. So and now you can see that when we move the arm, that whenever the locator gets in range of this cone, then the value gets driven. So when I'm actually hitting my target pose, I have a value of 1. And this is depending on, of course, how large the cone is. So in my case, the rotation of the upper arm goes to 75 degrees, and so in this case, I would have the angle of the cone reader be 75. Oh, actually the half, which would be 37.5 something. Or maybe, no, it's actually, bear with me, so 75, and then we have, at this point it's off, and then it just turns itself on until we hit the target pose. So now we need to connect the out value of the weightDriver. So select the weightDriver shape node, just select it, arrow down to select the shape node, and reload left, and we want to take the, where is it, out weight, and connect it with a blend shape node, reload right, and use the weight left arm down. You can see how the corrective is being driven. So this is how we're gonna set it up manually. Some steps, it's just doing all the connections is a pretty tedious thing, especially when you have lots and lots of corrective shapes. This is why usually everything is set up through shapes. So just to show this as a second example, first I'm going to delete the locator in the weightDriver node and set the blend shape value back to the default. Okay, just we can close this down and open, where is it, shapes. So I'm gonna load my mesh, and first we're gonna want this driving node being selected in the this shape driver list here. So just select it, right click, select from scene or add from scene, and we have this node here. So the same applies. I need to be in my target pose, so in the pose where the corrector shape should be driven. So this one here, so it should work like this. Let's turn on wireframe. Okay, this would be the corrector shape. So all I need to do is from the driver type menu select weightDriver vector angle. And since I have this driving node selected here, just shrink this list here, I can already see my parent joint. That's the gimbal node I have in my rig. That's what we used earlier as well. It automatically detects the joint axis, which is in my case the z-axis. Type is linear. The range is automatically set to 75 degrees. And yeah, that's about it. So we just click on the leftmost button, create shape driver. Yes, I want to create it, and I have hooked it up. So that's about it. And just to delete it, just select this button again, delete, and I'm done. So just to recap, select my mesh. So let's count the clicks here. That's selecting the mesh 1, loading the mesh 2, 3 for selecting this node, 4 for adding it to my scene, 5 to select the weightDriver. Everything is automatically set in place. 6, 7 clicks, and you're done setting up everything. So yeah, that's the basic workflow. Hope it helps, and if you have any more questions, let me know. Thanks.